Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam, and other exams related to physical science. Okay, so this is the lecture number 6 of the electronics. Okay, so in which I will solve some questions. Okay, and also about capacitor and and group combination, grouping of cells. Okay, well, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my detail to your friends as well, so that they can also be able to watch free live lectures and get benefited from it. Okay guys, so let's get started. Okay, so question of electronics is, so this is a question guys, it's a good question. Okay, we'll solve it. Just wait. This is hexagon shape. Okay, this is center, this one, this is the question guys, and we need to find out the equivalent resistance for this diagram. Okay, or this circuit. Okay, we have to find our equivalent resistance. So how we are going to solve this question guys? Okay, meanwhile let me check whether I'm audible or not, then I'll proceed further. Equivalent resistance, yes, I'm audible, so I'll proceed further. So you need to find the equivalent resistance for this circuit. Okay, so for solving this these type of questions, what we do is we'll add this with battery of 10 volt. Okay, so we have connected it with battery of 10 volt. Okay, this we have done, 10 volt, and so obviously it's 10 volt means the voltage at this point is 0 and at this point is 10. Okay, and this point it is going to be 10 minus x, and at this point it is going to be 10 minus x. Okay, and current are going to be, this is I1. Okay, by symmetry this current is also going to be the same. Okay, I1 and this will be I1 also. Okay, because of symmetry of this circuit. I1, let's say this current is I2. Okay, and if this is 10 minus x and this is 10 minus x. Okay, so these all resistances are R. Okay, which is given. So we have to find equivalent resistance for this circuit. This is R, 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 R. Okay, these are the resistances. So these are R. I'm not right. Okay, it's okay. Okay, so this is going to be and this is going to be X. Okay, so this is important, guys. So we have connected this circuit with 10-volt battery. Okay, this is the voltage at this point is 10 and voltage at this point is 0, and voltage at this point is going to be 10 minus x and this point 10 minus x, and then this point is 0, so this point voltage is going to be x and x. Okay, and this is so what we have done is we have taken voltage at this point x. Okay, x we have taken. Okay, 10-volt voltage is here, so at this point the voltage is going to be 10 minus x and 10 minus x. Okay, yes, well, so this is the circuit, guys. Now very simple, what we are going to do is and equivalent for equivalent resistance, what we can do is, so suppose the current is I. Okay, and this is 10 volt. I'm making equivalent circuit of this circuit. Okay, so this is like this. This is 10 volt and this is 10 volt battery, guys, and suppose current is I and equivalent resistance is R equivalent. Okay, R equivalent. This is the uh, equivalent circuit of this circuit. Okay, okay, so now, so from this circuit it is clear that total current I is going to be, this is I1, this is I1, means 2I1 plus I2, right? This current is I2 and these are I1 because of symmetry, guys. Okay, and the voltage at this point is this is given. Okay, so this point is at 10 minus x, this is 10 minus x, this is x and this is x. Okay, well, now so from here equivalent resistance is going to be, R equivalent is going to be simple, right? This is 10 volt and this is V upon I, right? V upon I, so V upon I, so that is going to be, V is 10 upon I is this current, right? 2I1 plus I, this is going to be equivalent resistance. Okay, this is going to be equivalent resistance. Now in this circuit we'll find the value of I1 and I1 and I2, right? And we'll put these value in this equation. Suppose this equation is 1 and we'll get the equivalent resistance. Okay, well, so now in this circuit, right, where voltage we have already taken, right? Now we can use KCL. Okay, using KCL, so by KCL, mean KCL, that is by nodal analysis, right, which I have already explained in my previous lectures. So this is the x at this point we are going to get. Okay, so this is x means, so we'll use nodal analysis. So x minus 0 upon R, x minus plus x minus 10 minus x upon R, minus plus x minus this is very important, guys. The voltage at this is going to get by symmetry, right? This is I2 and this is symmetry. The voltage at this point is going to be 5 volt. Okay, 5 and 0. Okay, this is by symmetry of the circuit. Well, so we'll use KCL at this point. Okay, so the nodal analysis. So x minus 5 upon r, this is going to be KCL x minus 5 upon r. Okay, this one, x minus 5 upon r plus x minus 0 upon r plus x minus 0 upon r plus this one, x minus 10 minus x upon r, right? X minus 10 minus x upon r equal to 0. Okay, well, so r will go in right hand side, this is going to be 0. So the value is going to be this one, x plus x plus x plus x minus 15 is going to be 0. Okay, so from here 4x will be minus means 15, 4x equal to 15, 4x equal to 15. So that implies value of x equal to 15 upon 4 volt. Okay, so this voltage is 15 upon 4 volt, right? So now at this okay, you need to understand this current is I2, this current, because by symmetry this there is current is I1, also current is I1, and this is because of symmetry, guys. Okay, the current is I1 and current is I1 because it is in hexagon shape. Okay, so this is the value of x we have found. Now we can easily find I1 and I2, right? So I1 is going to be here, this is I1, right? And we know this is I1 means potential difference upon resistance, right? So this is x minus 0 upon r, right? This is going to be x minus 0 upon r, and x value we know 15 upon 4 minus 0 upon r. So this is going to be 15 upon 4r, 15 upon 4r, right? And similarly we'll find I2, so I2 is going to be this one here, I2, this is I2, right? So 5 minus 0 upon r, right? This is going to be I2 is 5 minus 0 upon r, that is 5 upon r. Now we have got I1 and I2. We'll put these values in equation 1 and we'll get the required equivalent resistance, right? So from 1, R equivalent is going to be this one, 10 upon 2 I1, 2 into I1 value we have found, that is 15 upon 4R, 15 upon 4R plus I2. I2 value is this one, 5 upon R, 5 upon R. Okay, okay guys. Five upon R. So we'll solve it, right? Very simple calculation. So this is going to be 1 upon, this is going to be 1 upon 15 upon 2R, right? 2 will cancel this 4, plus 5 upon R, right? And this is 10 upon. So this value is going to be this one, 2R upon 25. Okay, very simple calculation. So 2R upon 21. So this is the equivalent resistance, guys. Okay, 2R upon 25. This is the answer. Okay, so this is the question, guys. So this is the answer, right? Very simple. This figure is we have been given, and we have to find the that equivalent resistance. So we have connected this circuit with 10-volt battery, right? At this point voltage is 10, so we have taken at this point voltage X. So by symmetry, at this point voltage is going to be X as well, and at this point voltage is going to be 10 minus X. Similarly, at this point 10 minus X, right? Okay. So now what we have done is, and by symmetry, current in this region and in this region is going to be same. Okay, by symmetry, I1 and this will be I1, and at this point suppose current is I2. So what we have done is we have made an equivalent circuit of this circuit. Okay, and from here R equivalent is going to be V upon I is total current is I, right? So I is 10 plus 2 I1 plus I2. Now what we have done is we have used KCL, that is nodal analysis, and by that we have found the value of X, and after that we have found current I1 and I2. We have put that values in equation 1 in this equation and got the equivalent resistance, guys. I hope, guys, you have understood it. Okay, next question, guys. Next question is question number 2. It's also good question, guys. Question number 2. Question is, okay, so this is the question. We have to find equivalent resistance. This is 10 ohm, this is 5 ohm, this is 5 ohm, and this is 5 ohm, and this is 10 ohm. Okay, so this one, and how we are going to solve it, guys. So this is a simple question, guys. This is based on Wheatstone bridge, right? Very simple. This is P, this is Q, this is R, and this is S. Okay, we can make this circuit like this as well, like this. We'll solve it by nodal analysis. Okay, so this is going to be like this. We can make this figure. This is the equivalent figure of this. Okay, so this figure we know it's a Wheatstone bridge, right? So this is going to be A and B. Okay, and this is P, Q, R, and S, right? So from here it's we will check it, is it balanced Wheatstone bridge or unbalanced Wheatstone bridge. For balanced Wheatstone bridge, we know the condition, right? That should be P upon Q should be equal to R upon S, right? For balanced Wheatstone bridge. Okay, this is for balanced Wheatstone bridge. So let me just check. P upon Q means that is 5 by 2, and R upon S is also 5 by 2. My apologies, 5 by 10, right? 5 by 10 equal to 5 by 10, that is 1 by 2. So this is a balanced Wheatstone bridge, right? So how we are going to find? So simple for this is the one, right? So this is the condition. So now what we are going to do is for finding the equivalent circuit, we will connect it. So it's a balanced Wheatstone bridge, so we don't need to go for it, right? We can easily find out. So this is R equivalent is going to be, this R equivalent is going to be this one, guys. Simple. This is, we know these are in series, and there's some is in parallel, right? So this is going to be simply P plus S, means this is P is 5 ohm, this is 10 ohm, this is my apologies, this is this is 5 ohm, this is 10 ohm, and this is 5 ohm, and this is 10 ohm, right? So simple, these are in series, so this is going to be, because it's a balanced Wheatstone bridge. And another question I will do, that will be unbalanced Wheatstone bridge. Okay, then we'll use the nodal analysis method. Okay, so here it is going to be, these are in series means 5 plus 10 into, I'll write in next page, the equivalent resistance is going to be 5 plus 10, because these PQ are in series, right? 5 plus 10 and 5 plus 10, and the P plus Q and R, their sum, these are in series, and their sum are in parallel, right? So 5 plus 10 into 5 plus 10 upon 5 plus 10 plus 5 plus 10, right? This one. So this is going to be 15 into 15 upon 15 plus 15 means 30, right? 30. This will cancel 2 times, right? And this is going to be 15 upon 2 or 7.5 ohm, right? This is simple, we know, right? If it is a balanced Wheatstone bridge, P upon Q equal to R upon S, this is the equivalent circuit of this, okay? Then we can easily solve it. Suppose suppose we have to find the voltage, okay? Voltage, that's we are going. Suppose we have to find voltage at this point, okay? How we are going to do that? I'm going to solve it for you, okay? So for this, what I can do is, I will make figure in next page, okay? Here, or simply here I'm going to make it, okay? So this is like, again, if you have to find the voltage at this point. Suppose we say voltage at this point is X, okay, and at this point is Y. Or what we'll do is, we'll connect it with 10 volt battery, right? 10 volt battery. We have connected it with 10 volt battery, right? So at this point voltage is 10, at this point voltage is 0, okay? And now what we are going to do is simple. Here at X we'll use KCL, okay? So this is going to be X minus 10 upon 10, right? This is going to be X minus 10. For X we are going to, okay, X minus 10 upon 5, this one, X minus 10 upon 5, okay? Yeah, X minus 10 upon 5 plus, at this point, X minus 0 upon 5, X minus 0 upon 5. plus this one, x minus y upon 5, right? Current at this will be 0, guys, okay? So x minus y upon 5, x minus y upon 5 equal to 0. Second equation for y is going to be y minus 10 upon 5, y minus 10 upon 5 plus y minus 0 upon 10, y minus 0 upon 10 plus y minus x upon 5, okay, and this one y minus 10 upon 5. This is y minus 0 upon 10. Okay, any mistake we have done? Yes. That's correct. So if you solve these equation, we'll get x equal to y. Okay, x equal to y. X equal to y. Okay, this is 5, guys. X equal to 5. Okay, well, so this is how we can find, but it's a balanced Wheatstone bridge, so we have directly found this one. Okay, because it's a balance, so we have directly found it by this because uh, these two are in series, these two are in series, and these two are in their sum and their sum are in parallel, right? So we have directly used the formula and found it. Okay, well, guys, so next question is which we are going to solve is, that is unbalanced Wheatstone bridge. Okay, next question. Next question is question third. Okay, so I'm going to make a figure for it. This is this is A, this is B, and this is 5 ohm, this is 5 ohm, this is 10 ohm. Okay, this is 5 ohm, this is 10 ohm, this is 10 ohm. Okay, so this is the figure, guys, and we have to find the equivalent resistance. Okay, so here we can see it is not it is a Wheatstone bridge, but it is unbalanced Wheatstone bridge. Okay, so because if you do P upon Q and Q upon R, P upon Q equal to R upon S, then it is not going to give that equal value. Okay, so this I'm going to solve with nodal analysis, right? So suppose you need to understand it. Okay, we have to find the equivalent resistance for it. Okay, so what first our step is, we'll connect it with 10-volt battery. Okay, so we have connected it with 10-volt battery. Well, right, and now okay, so now what we are going to do, this is current, suppose this is I, so this is going to be I1. Okay, and this is I2. These are the current. Okay, So first we'll make equivalent circuit for it. So equivalent circuit is going to be like this. This is current I, okay. This is 10 volt battery, okay, and this is the equivalent resistance R equivalent, okay, R equivalent. So what we'll do is we'll find, and so from here this is I, okay. So from here R equivalent is going to be 10 volt, right? 10 upon I, okay, or we can write 10 upon I1 plus I2, okay. We'll find I1 I2 value. We'll put this in equation 1 and we'll get the R equivalent, okay. Well, so this is the one, okay. So now again, so what, so this is very important step, guys, you need to understand, okay. Here suppose the voltage is X, guys, okay. Suppose the voltage is X here, so here the voltage is going to be 10 minus X. This is very important step, guys, okay. 10 minus X, I'll write in red, okay. So voltage at this point is X, we have taken, okay. So voltage at this point is going to be, this is X we have taken, and this is going to be 10 minus X. This is 0, guys, and this is 10, and that's why the voltage at this point is going to be 10 minus X, okay. So this is important step. Now we can easily solve it. So we'll use KCL here, right? Using KCL, so using KCL, that is nodal analysis, okay. So this is going to be X minus 10, X minus 0 upon 10, X minus 0 upon 10, X minus 0 upon 10 plus this one, X minus X minus 10, X minus 10 upon 5. Sorry, this one first. X minus, this is 5 volt, 5 ohm, guys, okay. X minus 10 minus X, or this is X minus 10 upon 5, okay. X minus 10 upon 5 plus this one is X minus 10 minus X upon 5, X minus 10 minus X upon 5 equal to 0. Very simple. Now we'll solve it. So this is going to be X by 10 plus X by 5 minus, this is 1 by, sorry, it's 2, okay, plus X by 5 minus 2 plus X by 5 equal to 0, and we'll solve it. So value of from here, value of X is going to be 40 upon 7 volt, okay. 40 upon 7 volt, 40 upon 7 volt. This is the value of X, guys, okay. Now we'll find this I1 and I2, right? So I1 is going to be, so this implies I1 value here, I1, this is I1, guys, okay, and this is also I1. This is going to be, I1 is this one, this is also I1, right? This is I1. So X minus 10 upon I1, right? This I1, this is going to be X minus 10 upon R, right? This is 5, X minus 10 upon 5, this is I2. I1 is X minus this is going to be or we can write this one, this I1. So 10 minus x minus 10, right? So this is going to be, this is x, and this I1 is going to be, I'll write it. So I1 is going to be x minus 0 upon 10. Okay, this will be also I1. Okay, so x minus 0 upon 10, x minus 0 upon 10, and we'll put the value. So x value is this one, 40 upon 7, 40 upon 7 upon 10 is going to be 40 by 70, or 4 by 7, right? So similarly, the I2 is going to be x minus 10 upon 5, this one, x minus 10 upon 5, right? And value of x, you can write it. So value of x is going to be 40 upon 7 minus 10 upon 5. Okay, so we'll solve it. This is I2, this is I2. Okay, so we'll solve it. So this is going to be minus 7, right? X minus 10. So this is the value, guys. So now what we are going to do is a simple calculation. So value of R equivalent is going to be very simple, that is this one, 10 upon I1 plus I2, 10 upon 10 upon I1 plus I2. These are the value of I1, I2. If you put it, then this value is going to be 7 ohm, guys. You can calculate it, very simple calculation. Okay, so this is how we solve it. Okay, very simple, which by nodal analysis we can easily solve it. Just you need to understand here in this circuit, this point is x. If you take this point as x, so this is going to be 10 minus x, guys. Okay, this is important step. Now then you just have to use nodal analysis method, that is KCL, and you need to find out the value of x, and then you can easily find out the current. Okay, well, so this is the answer, guys. Next question. Next is a grouping of cell, guys. Grouping of cells. Okay, grouping of cells. Grouping of cells. Grouping of cells. Okay, simple thing. Okay, but you must know it for solving question. Suppose this is a battery of E voltage. Okay, and this is R1 resistance, and again these are in series, E, and this is R2, and this is E1, guys, and this is E2. Okay, this is the resistance, guys. We can write this as like this. Okay, we can, because these are in series, so we can write battery together and resistances together. Okay, internal resistances together. So this is going to be like this. This is the equivalent circuit. So this is E1, this is E2. Okay, this is R1, and this is R2. Okay, this is E1, E2, and this is R1, R2, right? We can write like this. So in series combination, this you need to understand. In series combination, E equivalent is going to be E1 plus E2, okay, and R equivalent is going to be R1 plus R2. So this is the grouping of cells, okay, when they are in series. Now second is parallel combination, okay. Parallel combination. So in parallel combination, I'll make diagram, okay. I'll make it next page. So this is like, so we have this one, this is R1, this is R2, and this is E1, and this is E2. So E1, E2 are in parallel and R1, R2 are in parallel, right? In parallel combination, E equivalent is going to be very important. You need to understand this is E1 upon R1 plus E2 upon R2 upon 1 upon R1 plus 1 upon R2. Very important, okay? So this is the E equivalent, guys. E equivalent, okay? E equivalent. So so this is simple, and in parallel combination E equivalent is going to be E1 upon R1 plus E2 upon R2 upon 1 upon R1 plus 1 upon R2. Very important, okay? And similarly, R equivalent in this case is going to be very simple, R1 R2 upon R1 plus R2, okay? R1 R2 upon R1 plus R2. Next is, this is we are going to take as a question, okay? We have a question, okay, like this. We have given this one, this is R, this is R, this is E, okay, this is E. They are in parallel and there are n cells, okay, n cells are in parallel, okay, and resistances are in parallel, okay. So these are n times, okay, n times n. So we need to find out equivalent EQ we need to find out, and REQ we need to find out. Equivalent resistance and equivalent voltage we need to find out, okay. Very simple. So here you can see EER, these are N E are in parallel and N are in, okay, N resistances are in parallel and N voltages are in parallel, okay. So these are N times, okay. So how we are going to find out? So E equivalent formula we know, right? E equivalent, E equivalent formula is, this is we know, right? So E1 upon R1, right? So this is here E1 upon R1 plus E2 upon R. So they are simple, they are same, right? Plus 1, because they are so there are n voltages are in parallel. So on E upon R. This is n times, okay, n times, okay, upon 1 upon R plus 1 upon R plus 1 upon R, so on 1 upon R. This is also n times in the similar way, right? Like this. So there are two only. So E1 upon R1 plus E2 upon R1 upon 1 upon R1 plus 1 upon R2. So here we have n voltages are in parallel and n resistances are in parallel, right? So this is, so E equivalent is going to be E equivalent is going to be E equivalent is going to be E equivalent E equivalent is going to be this one. So this is n times, right? So Ne upon R, and this is n upon R, right? Ne upon, because they are added n times and they are also added n times. So n upon Ne upon R upon Ne upon R, right? R will get cancelled and NN will get cancelled, right? So this is going to be E. If this is the combination, right, E equivalent is going to be E. Okay, very important. Now we will find, okay, yeah, this is the answer, guys. Okay, this is the answer. Next question we are going to solve. Next question is next question is, this is also a good question, guys. This is grouping of cells. Okay, R R R. So this is n times, guys. Okay, n times. Again, n times. This is also n times. Okay, so here this is going to be like this. This value is going to be like this. Okay, this is also n times. Okay, and here they are m times, m times, m times, m times, m times. Okay, so now we need to find out that E equivalent and R equivalent. Okay, E equivalent and R equivalent we need to find out, and options are, option number A is Ne comma Nr upon M. Option B is E comma Np upon M. Option C is Ne comma N upon R, Nr. Okay, and D is going to be Ne, and this is N upon R upon N. Okay, and option D is Me comma Nr upon Nr upon N. These are the options given, guys, and this is the question. Okay, so how we are going to solve it? Okay, so very simple, guys. So you can see these are in series, right? So these are series, so there are n cells and R resistances, right? Similarly, n cells, R resistances, and if you go down, so there are n cells, m times cells, right? So first we'll find out this one for first row. Okay, for first row, we are talking about this row. Okay, so R equivalent is going to be, because they are in series, right? So this is going to be N is this and R resistance is, right? So N is going to be this one. We have found like this, right? So this one. in series, E1 plus E2 plus E3, right, are E equivalent in series. So this is going to be, so first row, E equivalent is going to be NE, right, NE. Okay, okay, and now you can see here these are in parallel, right? In parallel the voltage is equal, right? So so in that case E equivalent is going to be NE, right, because voltage is same in parallel combination, right? Next is next for second row also this will be, for second row also EQ will be equal to E1, or we can write E2 is going to be NE, and first row that E1 I'm denoting, okay, that is NE, right? So NE equivalent is going to be NE because voltages are same in parallel combination, right? Or A3 E4 you will find that will be NE, okay, that is E equivalent. Okay, next is R equivalent we need to find. Okay, R equivalent, this is important guys. R equivalent is going to be, you can see, so there are n resistances in series, right? There are n resistances in series, there are n resistances in series m times. Okay, so R equivalent is going to be, as we know, right, this R1 into R2, this one R1 into R2 upon R1 plus R2, right? So this is going to be, in this case it is going to be very important step. So this is going to be NR upon M. Okay, so this is going to be NR upon M. This is important guys. So this is, so R equivalent is this, E equivalent is NE. So which option is matching guys? Let me check. R equivalent is NE and sorry, N E equivalent is NE and R equivalent is NR upon M. So option A is matching, right? NR upon M. So this is the answer guys. Simple question, right? This is the answer. Okay. Next is, this we have found out by this simple way, R1 into R2 upon R1 plus R2. Okay. Next is, next I'm going to give some idea about capacitor. Okay. So capacitor, then in next class we'll solve some questions. Okay. Capacitor, if we talk about, if we talk about the capacitor, so suppose this is a circuit and this is the capacitor. Okay, okay, so this is capacitor and this is the voltage guys. Okay, this is not capacitor. So voltage is, we suppose this is plus and this is minus. So this is plus and this is minus. Okay, plus Q and minus Q, right? Plus Q and minus Q. Okay, plus Q and minus Q. This is the, this one. Okay, so initially what happened, you need to understand initially, so that we can easily solve questions, okay, of circuits where there is a capacitor, okay, attached. So initial stage, at initial stage at t equal to 0, Qi, that capacitor Qi is going to be 0. Okay, so in that case this is a capacitor, okay, and it will work as short circuited wire. Okay, short circuited wire, because Qi is 0, so it will work as a short circuited wire. Okay, and second is at any time, at any time t equal to t, Okay, so this is going to be like this. Okay, this is the capacitor, plus and minus, right? This is voltage. Okay, so you can see, so it is here V voltage is going to be QT upon C. Okay, or Q at any time t, Q is going to be QT, right? Or voltage is going to be Q upon C. That's the formula we know, right? This is the one. So in this case, this is the second case, right? The third case is at t equal to infinity. At t equal to infinity, where t value is very large, okay, then QF is going to be, QF is going to be CV, right? QF is going to be CV, that implies capacitor is fully charged, okay? QF will denote it by QF. So at t equal to infinity, okay, capacitor is fully charged. Capacitor is fully charged, okay, or this is called steady state. Okay, it is called steady state. And at this stage, capacitor is going to work as open circuit, okay, open circuit, right? Open circuit. At this point, I is going to be 0. So at t equal to infinite, capacitor is fully charged, and and that will be in steady state, and it will work as an open circuit. At initial stage, it will work as short circuited wire, okay. At any time t, Q is going to be QT, and that from there the value of V is going to be QT upon C. This is a brief idea about capacitor. Okay guys, so well guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, okay guys. And also guys, I would request you, please share my details to your friends as well, so that they can also watch my free live lectures and they can also be benefited by it. Okay, thank you guys, bye now.